Yep, het gördüğümüz. But shall I move this also to a member function of pointer tag? Hello, Utkarsh Kumar. I'm working on a simple segregated storage class. Most notably, I want to put the characteristics of it in template arguments. I think I successfully put all characteristics into this pointer tag class, so I could just make that template argument and then I'm done. No, I'm not rushing. Yeah. I don't know, man. Because of the usage of FreeNode here, I feel that probably should not put FreeNode in the pointer tag class, right? Nah, probably not. But if I put it here, then it's defined inside the template class. That depends on pointer tag. It's almost the same thing. And I could move it lower, but also using it here. Allocate. Suppose I can solve that. By allowing to construct it from a void pointer. Except that I need a new front pointer here as well. Yeah, I just need to. I need to have the free node object already here. It's confusing. I would almost make another base class, the base class of this base class. Maybe that's the solution. Okay, I'm gonna put it outside everything. Super lame. True. Okay. Hi, you True. I'm definitely pronouncing that incorrectly, but I'm trying. So, what kind of word can I use for, say, a simple segregated storage with the possibility to allocate more memory, but then shorter? I'm from the Netherlands. Kunnen dit ook in het Nederlands doen als je wil. Yeah, let's fix the ABA problem first. This means I really have to do the tagging stuff. I can't even reproduce the problem in my test suite. Kind of pointless, but oh well. Yeah, you have to try really hard to get that bug to appear. Maybe I should write a test and add some debugging code to the segregated storage, and then well, that will allow me to reproduce the ABA bug, and then write a test that actually triggers it, and then write a code that fixes it, so I can actually see that it works, as in, yeah. Shall we do that? Let's see, I have this working now. Maybe first do a commit and yeah, it totally works. I don't know what else to call this, and work in progress. Split out pointer tag or something maybe. I don't want to have this yet. It's just a memory map. Git commit. In order to reproduce this, I need to be able to halt a thread in the middle of where it is working, which I think is in the header. I need to be able to halt it here. I can do it inside next. Oh, that's awesome. I can write a test that defines pointer tag. So I just create my own simple segregated storage using a different pointer tag. Doesn't that require me to? Then I also have to do these things, which is kind of annoying. Let me think how to do that. That one is short enough with the add block. It does work on the head, m-head. Damn it, it sucks. Shall I make this a template as well? Yeah. For now, anyway. That was nonsense. The last one is a function name. That is the class. Specializing member. Try allocate more. Requires template syntax. It's not my intention to make that an now these also have to be templates. No. Yeah, I'm not gonna do that. Okay, so what I want to test is ABA. Just call it let's call it the ABA test. Actually, I only want to have the segregated stuff here. So we have to redefine this because I want to use a different pointer tag. Just define it outside namespace memory, but this one is still inside memory. And then, yeah, I'll just have to duplicate this code. That sucks. And of course we want to define our own pointer tag here, so let's start with copying that as well. Now I didn't change anything yet, so now this simple segregated storage should be exactly the same as the memory simple segregated storage, just a copy. So let's define test function. And then we do the following. I need one thread to thread 1 run yeah, I can just don't have to do this. Let's just call this one action 1. Huh? Why is my spine typing string? I wanted to type thread. I was even thinking thread. I accidentally hit S and then the rest came automatically. Well, that should be compilable and testable, and that should print leaving thread twice. Except of course we need a debugging header. Right, and then we need to add this thing. Add executable maybe a test. No such file or directory. I think the thing hides in memory. Yes. Farina does not name a type. And pointer tag. Yeah, okay. Also memory. Is it how did I always forget how to do those things? Apparently this works. Use without template arguments. I'm sorry. It's weird actually, because I didn't have to do that in the thing that I copied, so in the original. Well, whatever. Okay. ls resource ABA test. So thread action 1 started and then exits. Yay, that works. Now to make it do something, I need an instance of this class, and the bloody threads need to access that as well. I'm not gonna pass it. I'm just gonna, well, I could pass it, why not? Okay, I mean, global things are so evil that I don't want to do that. So I'm making my simple segregated storage object here, and then we'll pass it here. And obviously you have to pass it by reference, because we both need to use that object here. Yeah, things shouldn't even be copyable. Right, now action 1 is going to do the following. It's going to call allocate. That should give me a fixed size block. But nobody knows what that block is. And in fact, this allocate is going to find out that we don't have enough memory. Which means that my lambda is being called, and the lambda is being passed here as well. What the hell? What is a lambda again? Well, here's an example, I suppose. Or not. No, let's look here. This, we need a function that takes nothing and returns a boolean. This should work, as long as it returns a boolean. And we're going to be successful. The word successful means that we allocate a new memory, and we can allocate new memory by calling on SSS new block, or what was it called? Add block. So this is being called with our add new block. Maybe we should call it add new block then, or oh no, it doesn't have a name there. That is then going to call it. It's being called here, and then, well, that's our lambda. So the lambda is now being executed, and then the lambda has to call this add block, and then just pass the block and etc. Let's see. Okay, so I need a new block. Doesn't really matter what it is. Let's just make that a global thing then. So we're having a static array. Gars. How small can I make that thing? I think even 16 bytes should be enough. Let's make it 32 bytes. I'm feeling generous. Then the partition size is let's make that a const expression. Absolutely not needed, but since it's a global, I feel better if I do that. That is too small. 64 then. Hey, no, it has to be a constant expression. Ah, I have an excuse. I think add block itself can also fail. That is add block. No, it cannot fail. Okay. So we just call add block and then return true. I think that should allocate my memory. As in add 4 blocks to the simple segregated storage. And then it should return, of course, a pointer, at which point the pointer must be equal to the first block, because we're the only one that allocate data. Yeah, so the big block here exists of four little blocks. Very confusing. Sometimes it's called big block, otherwise it's called block. Allocate, no, call them nodes, whatever. Okay, block is a big block. I have 4 nodes here, I'll call them nodes then. We have 4 nodes and we get the first one of it. So the first one, or the first node of block is definitely going to be what is being returned here, even though it has just been allocated there. I'm just going to try to compile this. A pointer equals, yes, and I didn't capture the SSS here. That must be captured by a reference still. Oh, and lots of other stuff as well. I have block and we have partition size. I don't have to capture partition size, I think, because that's just accessible. Is a const expression. I don't think I have to capture it. No, that would be ridiculous. But we have to capture block also by reference. Capture block by reference. Variable block with non-automatic storage duration. Warning, capture or variable block with non-automatic storage duration. Apparently we did not have to capture that. Okay then. Static assertion failed. Standard thread arguments must be invocable after conversion to R values. I'm not sure what it's saying there. Not sure at all. What's wrong with this? Oh, you have to use standard ref. I'll pretend that I understand this. It's like I never used standard ref before, but now we know. Okay, so can also run it. Let's run it. No crash. Isn't it amazing? Okay, so now I want this thing, while it is allocating, to stop in the middle of something, and that something is while calling next. So here this is my next function. If this is being called, at the moment that this is being called, actually it's after that this is being called. So just before we return something, after reading the mnext here. So here we're going to wait for something. How shall I call that something? Well, ABA, of course. ABA happens. Wait. So here we're going to wait until the ABA happens. And the ABA happens, and then must be known. I'll just make that a global thing again. SimpleSegregate. Yeah, the other threads should wait until we get there, until we get here. Let's use another gate, I guess, because those are easy to use. So next has been read. Open the gate. Make another one. And then this action here must wait until that has happened. I think this is going to fail now though. And anyway, anyhow, even. Is that true? Yeah, let's just continue. Okay, so we get here. The action 1 has read the next value and it's waiting. So now we're going to allocate two things here. So I have the first one is my A value. And this is also the A value. It's going to read the same value as here because this one didn't finish yet. I didn't write ahead. It's waiting for us. When just copy this again. But this one should never have its lambda be equals, because now we do have memory. I only have one array in the anyway, so. Should never get there. And then we read B, allocate B, and then we deallocate, you guessed it, A, which puts A back on the head, so that compare and swap is going to succeed on that one. Yeah, this one has there's a successful A, so that is totally equal to block, and the B is then equal to the next block. So maybe I should do yeah, I'm just gonna do block data plus partition size. Well, maybe, well, even after deallocating it, right? I mean, it's a static array, so a global array. Now I'll put it like that. I'll put it in like that. I can even put it here. Okay, so we allocate 2 blocks and then we put one back, and then after putting this one back, we're done, I think. So I can do ABA happened, open, put the other gate open as well, and then this thread starts running again. And this thread, yeah, whatever. I mean, I don't deallocate B. Why would I do that? In fact, now this one runs again. What it's going to do is it gets A, because A was freed again. Yep. But something went wrong. Because the next pointer is now pointing to, oh boy, I don't see it in front of me. Let me think. I'll do some ASCII art, but a really simple ASCII art. So I just have block 0 here, followed by block, actually block B. I'll just call it A, B, C, and D. That's the array. Then, well, after this one, yeah, after this one, head is okay. So after 1, we have head points to A, which points to B, which points to C, which points to D, which points to null. And what we're going to do here is we read the next pointer of A. That becomes B. And then we stop. Now action 2 is running, and that also gets, well, it gets A and B. So after 2, we removed A from the list, so now head is pointing to B and so on. After 3, we have, well, removed one more, so then points to C. After 4, we have, now A was put back on the list, so now head points to A, which then points to C, and so on. And B is still allocated, not on the free list. And this is doing nothing anymore. So now we ABA happened to open, the gate is opened, and therefore this thread starts running again. So now action 1 is doing continues and does. Now since head is pointing to A, the cast is going to succeed, meaning that whatever it read as the next pointer, and that is B, is going to be written to head. So afterwards, head is going to point to B. Is there any other thing that's going to, no, nothing, right? So just only head is updated and then we're done. And it returns A. B is, is allocated, so It has a next pointer, which still points somewhere, maybe, but let's override that because you don't want to. If you allocate something, then just override it. Do a mem set to 0 or something. I'll just fill it with all ones or something. How do we do that? Standard mem set a. Okay, so if you don't do anything else, then nothing will crash, because head now points to B and B is filled with all ones. But if you never use head anymore, then why would you? It won't crash. Let me think. How can I test that? Or what happens afterwards? Nothing, right? Nothing, nothing, nothing. Yeah, I think it should not crash. Let's test this. That's in threading. It does not crash, but it hangs. Okay, this is the main thread. It's just waiting for stuff to join. The more interesting are threads 2 and 3. That also looks like it's waiting for something. Condition wait, condition variable, yeah, it's waiting for a gate ABA happens. It's waiting for ABA to happen. Well, it's in its right, I would say. So action 1 is started. That calls allocate. That calls next, and then inside next we call wait on the gate. That's correct. But the other thread, that is action 2, because this is action 1. Thread 2 is action 1. So action 2 should open that gate. So why are we still waiting for it? Thread 3, backtrace. Action 2 is started. It also calls allocate. Ah, yeah, that also calls next. Yeah, indeed. Okay, never mind. So I only want the first thread to wait here, not the other thread. We just want to do it once. Could do standard once, but that hardly seems necessary because of the synchronization that I already have. I'm just going to do if first time do this. Probably better to set that to false before I open the gates for the other one. So set this to false and then we open the gate. And then the other thread is also going to read this, so it probably should be an atomic, despite that we have other synchronization stuff in place. Let's make it an atomic, because yeah, well. I'm putting it in here, why not? Static, standard atomic pool. First time, and I can initialize that. True. It's a non-atomic initialization, but that's fine because it's just a static. I bet we have atomic already. What is this? In-class initialization of static member. Const expression needed. Yeah, it's totally not a const expression. Yeah, that's not allowed. Oh hell, then I put it outside the class. Who gives it? And that made it work. Awesome. And as expected, no crash. But the ABA bug happened, so let's make it crash. Because after all of this, we have head pointing to B, which is still allocated. And filled with all ones. So if I do anything with head and would try to read head next, for example, that should crash. So if we try to allocate once more, that's still in action 2, why not? I have to wait again, huh? Don't I? I'm just gonna wait until this all over. So after the joins. Let's call SSS allocate. And that should give us C. Because B is still allocated. And A is allocated by action 1, also still allocated. This tries to allocate A, and then this allocates A and then B, and then frees A again, and then that one gets A, and then now this has A and this has B. And if we do allocate something else, then we get C. And I can even test that here with assert as well. We expect C to be the third block. Well, we won't get here because this is going to crash, this call. It's not crashing. Well, it's asserting, but it has returned. It's just C is not what we expect. How is that possible that it not crash? I'm gonna debug this. Steppity step. GDB. After all is said and done, we are at 158. Continue. Call S step. Allocate. My God, I should have stepped. Does start to run my. I have no idea what it's doing actually. Is it creating the lambda? Okay. I think I can do finish. I'm not sure. It's just a current function. Then where do we end up? Allocate. We're there. We are there. We're now in line 109, and head should be pointing to B. Can I print block from here or not? Data. Stupid debugger. There's nothing inlined here. Yeah, that looks B. I mean, the beginning of the array is this, and then that is 16 more. And my partition size is 16, so that's B. And the contents of that should be all ones. Which it pretty much is, isn't it? Yeah, repeat 32 times. This is octal 1 1, lots of ones. Why the hell is that octal? Now I have to count. 3 plus 3, okay, 8, it's a char. It's a char with all ones, repeated 32 times. It means that A and B both, which are the only ones that are allocated at the moment. They're all ones. 16. Wait a minute. It's a char. Yeah, okay. So 16 bytes is for A and 16 bytes for B are all 1. And this is still random stuff because I never filled it with zeros. Oh, random. Maybe this is a next pointer. Who cares? Probably next pointer. Yeah, there must be one next pointer in it. So this thing points to that thing, and that thing is 0 because it's the last element. That's not random. Static objects are filled with zeros. So this is definitely the pointer to that one. So far so good. Frame. That is loaded into head tag. Okay, next. Print head tag. Rather print head tag pointer. Yeah, so there's block plus 16. which is B. There's our thingy ending on F0. And we can also print the tag. We don't have tags, so probably 0. Oh, even better. We don't have tags, like literally no tags. Who cares? Yeah, the encoder thing was already that. So if there were tags, then they would have been 0. See, so that's basically the 0 over there. The last 2 bits of it. And that is not equal to end of list, because end of list is something that ends on, it's just 3. 3, yeah. Just totally not 3. Next. The new head tag becomes the next pointer of the current head tag. Now this should be read from B and therefore be all ones. Let's see if we can verify that. So we do step, enter next. We get the pointer here, the pointer of the head. So again, front node here is pointing to B. Yep. And then we're reading M next, so this should be all ones. I guess I never dereferenced second node. It is all ones. Okay, so far so good. I was just mistaken that that's not going to be dereferenced. So what happens then? The second node is now bool issued and first time is off. So we're done here. It just returns nonsense. Do finish. Print new head tag. What? I didn't assign it yet, I think. I just have to do it next. Yeah. So the new head tag is now all ones. To garbage that we read. We're going to try to write that to mmap-ed, which succeeds because mmap-ed equals to this head tag. So I do, see, we can print mmap-ed tag here. Which has some same value, and this one has the same value, or optimized out, of course. Yeah, really, I don't think so. Anyway, we do finish, and that returned nothing. Okay, I think I can print this one again, and now hopefully we have all ones in there. Yes. But the cause should have succeeded. Therefore, we're going to do this. Yes, we do. And then we return lots of ones. No, returned is this. Oh, it's the old value, yeah. Which is B. Huh? Why is it returning B? Oh, because head was pointing to B. Duh. Oh, so because of the bug, C becomes equal to B, while B is still allocated. That's another way to test it then. Yeah. So this fails, indeed. And which is sufficient test, because of the bug we get B back. And B would be 1 times the partition size. Whew, okay. And of course we're also not very happy with the fact that mmap-ed is now really corrupted. So if I try to allocate more, then we do crash. Come on, I want to see a crash. Let's allocate another one. That's not going to happen. But if it would happen, then that's going to be D, obviously. And then we allocated all of it. Yeah. Now we have a nice segmentation fault. Right, so now if I fix the ABA thing, then it should not crash or assert, it should just work. And we can do that by adding the tagging, but then I have to edit this, I think, because, well, it's a copy, but I have to add the tagging here. Okay, so the pointer tag itself is being constructed with some tag that is being passed here. So I don't have to change this. I have to change the real code. I bet I also need to be able to access a tag. And the construction, I mean, where's the tag assigned? Just here. Yeah, in here. Although this is only used here, I thought. Only used here. That would still be the constructor here. That's why I hate the structures. Everything is public, but I can't make it private. I can't make this private because of the direct access from that one cost thing. It's just a test this. Well, I don't know. But now it's not certain. It's just I seem to remember that probably this is the only point where we supply a tag. Which then also happens here. So when do I need to increment the tag? That is the question. So we want to avoid the ABA, which means that the A is being read, and by the time I deallocate it, must be incremented at least once. I would think that that means that we have to increment it only either when allocating or when deallocating. Not both. That seems not necessary. Yeah, I'm sure of it. Just one is enough. And then the thread that is going to compare, that is the thread is going to call this next, and then, well, wait here. In this test case anyway. If that's going to do some increment, then it might not be enough. I mean, let's say, I don't know, we are incrementing it already, then we get a plus 1, because that's what you want to write back or something. No, that's nonsense. What the hell does this not highlight? Oh, my syntax thingy doesn't understand the GNU always in line. Or the syntax isn't understanding it. It should be understanding it because I can jump to it. Weird. Okay, anyway. This is the header file. What am I looking for? Allocate. So a head tag here becomes A. And if I would increment the tag, that means that I write back to the head. Something with one more, but it doesn't really matter if I do that here, because I'm still comparing it, of course, with the old tag without increment. So if someone else then succeeds in doing this, then the tag of the head increases with 1 and then won't match this head tag anymore. So you can do it either in allocate or in deallocate. It doesn't really matter much. Let's begin with preserving whatever the tag is, and then think about incrementing. So this new head tag is read from next, which very explicitly currently has a tag of 0. So preserving the tag would mean that whatever this is returning returns the same tag as the head tag has. Because that's what I'm writing. So I could look for all calls to guess head tag and then make sure that whatever we write as a second argument here has the same tag as what does this thing, which means that the next must return the same tag. It currently is not doing that, which is not good. So in order to fix this first one, go to next, and we return the correct tag here. This tag now must be the tag of encoded. Code duplication. Yeah, that totally sucks. Okay. Code duplication sucks. Lost tag. I can't even find my other one. No, why? Or maybe I didn't write it yet to the disk. Oh, it's even better. Okay, I probably can remember what I did. I think I moved this down. And then I put the tag below it, and it had this type, and I call the tag. That was const. And it returned, and then I returned encoded and the tag mask. And then I could call tag here, or do the same thing, encoded in tag mask. This now preserves the tag. And then we go to the next cache head tag, call here. I thought I had 3 of them. Okay, this is a deallocate one. And then in the header there's nothing left. I'm first going to look for the third one, that is here. This is an allocate one as well. And it is doing new tag, which also uses as tag 0, but I want to use the same tag as the head tag. And the head tag wasn't even defined yet. Plus The head tag is updated. Head tag is updated upon failure. So then we go here and then we would use the wrong tag for the new head tag. So it cannot be const. Unless I make a point of not incrementing the tag, of course. No, that's nonsense. If it changes, then we have to reread it. It could be changed in the meantime. Well, I have to, otherwise it keeps failing. Is that not true? Yeah, probably. Okay, so the new head tag here has to be constructed in the loop. From first node and a tag, namely the head tag, and then the tag part of that. That will preserve the tag of the head tag, but the head tag is updated here upon failure. So we load it, use it, and then upon failure we do it again. It's not that bad that it is moved inside this loop, because this only fails once every, I don't know, million time. Depends a little bit, but doesn't fail often. So it is more or less still the same thing. Well, it's now done after that one instead of before, but also that doesn't matter. Well, actually it does matter. Yeah, we load this, load it, and then I use the tag of it. Definitely makes a difference. Okay, this one is now adding a new memory without incrementing the tag. But adding new memory is kind of like deallocation, isn't it? Yes, it is. Wait a minute, man. This is not the ABA problem. This block here is completely new pointer. So head is never going to be equal to whatever another thread was still keeping around. So it doesn't really matter here what I do. Well, I could set the tag to 0 if I want. Deliberately. Talking about a new head tag. The new head tag is made from the first node. It is completely new block. Well, that could have been recycled. A very idea. Yeah, no, that's not gonna happen. I'm just gonna use a tag of 0, I think. Like that. Maybe add a comment. And use a tag of 0. This is a new block anyway. Completely new block. Yeah, okay, so we can ignore that part. Then we have here first one I did take care of. That was because the next has been taken care of. And now this one. The new head tag here should be... here we need that change. So the new head tag must be done there, and then with the tag of the head tag. Which now preserves it. I feel like incrementing it here though. Preserve it in both places, and like I said, it should not matter, but okay, I'm just gonna try it. Let's try it. So I increment it here, and then it should work. The ABA failure should go away. Well, let's first do this. So now preserve the tag, but it should still fail because I'm not changing it. I'm just using the same tag. So tag stays at 0. It's going to exactly the same thing as before. Oh. Or I could just do a return there instead of a break. Okay, nice segmentation font. Still same, exactly the same. What are we even talking about? And then let's increment the tag. Now it should work. And it does. Awesome. And I think that if we do not increment it here, but we increment it where we allocate, I have to do that inside next then, I suppose, yeah. Well, let me... Really? What? List? Yeah? Oh, next. Yeah. Help. Get me out of here. What? This thing is returning 0 still. Oh. So bad. Yeah, not good. Hopefully they are the same now for the rest. So this should crash. Yes. And then I'm going to add one here to the tag. Okay, the mask is applied here, so I can just do tag +1. And then that worked as well. Yeah. Very good, very good. But. Yeah, maybe it's better to do the +1 under the control of pointer tag. I don't know. Let's leave it like this, I guess. Which means that now we have to do this also in the header here. Good. I think I'm done for today because it works. I mean, next I have to do the MemoryMappedPool, which is the reason that we made all these changes. Why would that not be automatically set? Strange. I don't get it. Yeah, memory map. The map needs its own segregated storage called mapped segregated storage, and we just call that. And then it should work, hopefully. Except of course that this doesn't exist yet. The memory page pool is derived from the memory page pool base and uses the simple segregated storage. And then overrides allocate and deallocate. Allocate passes a lambda, while the memory map pool also derives from memory page pool base. Defines this, and then we have an allocate that does not pass anything, which is okay, I guess, as long as my mapped segregated storage has an allocate that is not needing a lambda. I'm probably going to have to look a lot at simple segregated storage, as in, hey, let's choose a license. Yeah, I left Liberia because I got sick of it. Maybe I should change my TPG. Second year now. So bullshit. Don't need a sys in a header. I need a base, right? So you need to include this. Yeah, it's not entirely true this. But it is a beginning. So one of the things is that if we try to allocate something and we are at the end of the list, then we are at the end of the file. There's no extra allocation possible. So that is just return null. Allocate will return null because there is, I mean, the base class already does that by itself. So this is going to come here then, end of the list, and then it calls try allocate more, and the default try allocate returns false. And therefore then we return a null pointer. So this false. And the second change is that, well, difference I mean with the other one, is that if we read next here, and that is null, then that does not mean that we are at the end of the file. Ouch. Not necessarily. In order to know if we are at the end, my mapped pointer tag yeah, this is not good. What the hell? It is not working out. I need more data here. I need to know the size of the blocks and the end of the file. But this is just a type. So the only way I could do that is if those two values were fixed values. Which is unfortunately definitely not the case. The memory mapped file is, I don't know, somewhere, but the runtime, where it is runtime determined. Arg. Well, that is around this point, and now I think about it, we should even not call this, because this thing has an allocation lambda, which I don't want even. Who's going to call that then? I think I'm just going to compile. How is simple segregated storage not totally including this? What? Oh, it's a constructor. Map-ed pointer. Have to derive from it. Yeah. Okay, so trying to call allocate on it tells me that, yeah, we cannot use the base class because that takes that. But we can copy it and then we have to put that in here, right? I think so. Let's begin with copying it. No, that must be in here. And then suddenly we have way more control here over the next, the call to next. Like we can just pass the arguments that we need. So it feels totally fake though. Why am I using pointer tag here instead of mapped pointer tag? should be able to run the same test now using the memory mapped one. It will fail, but it's the beginning. Let's say, now go to source. Let's say we go to, could even do the ABA test. Just, no, that's not going to work then. I need the memory pool thingy. That's not it. Memory mapped test. Can use this. Yep, this creates a pool. Then after that we should be able to allocate a memory format now. That's a big size. Build a map file, blah 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 of size. What? Because this is being called. Why? Now it looks sane. Why does it look sane now and before it didn't? What is that? the file does not exist, we got nonsense here. Mapped size. Do you know size of is not a function? Yes, I know. It's not a function. I use parentheses, right? Is that why you say it? I think I'm going to stick to it because it works. I'm used to it. That the correct mapped size. So this is not happening if my file does not exist. Or maybe we get here and I don't know. Let's see what happens from the top if there's no file. File name. Absolute file name, path. Status, file status. File exists. File does not exist. Else if file does not exist, if file size is 0, no. If mode is read only, I can't remember. Probably not. Otherwise you would have gotten an error. So this, and then none of that. Also not this, but this is just error handling. So the error is not set, so we don't throw. If the file does not exist, still doesn't exist, open it. That succeeded. Do a stat on it. That succeeded. The size is 0. F allocate file size. Yeah, that succeeds as well because you can see it in the ls. But mapped size is not set. Still not set anyway. So file size is now correct and set, and then we get here, this is skipped. Map file to virtual memory. Yeah, map size should have been set already. Yeah, map size. Okay, so map size is set if we get from here, because it's always set here, or maybe somewhere else. But not here. So this is missing here. The file does not exist, then of course file size must be non-zero. That was already tested. I'm just setting mapped size is file size. Just created it. And now it's permission denied. But at least the size is not correct. Why the hell would I suddenly get permission denied? Okay, so this is being called, that gives me permission denied. And the file exists in the meantime. And that still makes a difference, because if I run it now, well, it coordums, but I don't get a permission denied. Or maybe I do, but I coordum before I get permission denied. Why do I suddenly coordum? Did it happen before? This looks exactly the same. Yeah, this is just the same thing. So, I don't know. Why am I core dumping? Am I core dumping again? Yes. It's very reproducible. Run. Oh, this is just the pointer's null thingy, isn't it? Continue then. Segmentation fault. Yeah, and pointer is 0. Which is because it wasn't implemented. I'm working on that. I don't get the permission denied if the file does not exist. It's ridiculous. So I get this because did I not close the file yet? What is FD then? I allocated it, but then didn't close it again. Probably opened it in the wrong way. Yeah. Create write only. Yeah. Try to create a file. We need read permissions as well. I'm just going to do the use that. I think that was the problem before as well. Just need to read permissions. Yup, no, we don't get a permission problem. It's the same thing as when the file exists. Just the pointer is 0. I'm gonna quit for today though. Tomorrow I will wasn't I? Yeah, I was testing something, right? Something. Can I not quickly test it? I think I'm pretty close. Maybe I should finish it. So what I have is that we get the next pointer. Is null at some point. That's mapped segregated storage. So we're reading this next pointer, and that is null, and that is null because I refuse to fill the whole mapped file with pre-allocated free list thing. So my whole free list is just consists of null bytes. But we know that if that happens, then the next pointer actually should have pointed to the next block, as in offset. So if I know the offset of the current block, then I just add the block size, and then we get the next pointer, and I should be using that. So here we can do if second node equals a null pointer. The out fatal DC core implement this. Now why would we get here if we try to allocate something and the head pointer is even 0? Well, the head pointer is 0. That's how it begins. That ain't equal to the end of list. So we get here, but with a head pointer that is 0. Ouch. Okay. Yeah, this is 0. Front is 0. This doesn't even work. I think I should initialize the head pointer at the very least. So the head pointer is not 0 initially. How can I do that? The head pointer is a member of the SimpleSegregatedStorage base here, and this does not allow me to construct it with the value. Hell, it's always set to end of list. Yeah, but no, I don't. Definitely don't want to do that here. It's such a mess, man. I tried so hard to combine everything from the one that allocates with malloc and the memory mapped thing that I still had to write in the future. But not much reuse of code there yet. I need a special constructor here in the base class for my memory mapped case, namely where I can set the initial value of the head pointer. I'm just going to use a tag of 0 here. Let's just pass a pointer. Void pointer, begin. Yeah, see, this is super specific for the memory map thing. Why am I adding that? Why do I have to add that in the base? I hate this. But okay, let's first make it work, and then maybe can move stuff around so it becomes a little bit more logical. Theoretically, this should be using encode. Pointer tag encode pointer comma 0, so we use a 0 tag. I'll just call it head, I suppose. Okay, construct this way it doesn't look too memory map specific. Although the only reason that we already have a free list here is because my whole mapped file is one big free list and I'm not even going to allocate. So this is what I need to call then in the case of the memory mapped thingy, and this is well, base class of this thing now. So it no longer default, so we have to the default constructor, so you have to explicitly say using the constructor of the base class, and then we can just construct this using the constructors of the base class, including now that other one, and then you still have to do that. So now this must be constructed with. Actually, I could even remove the default constructor, because currently it is default constructed, but that is nonsense. So let's not inherit the default constructor. Let's just define our own constructor here, which takes an a void pointer. It was so void pointer, and then. Yeah, in the base class called head here, maybe I should call it begin or start or map start. I'm gonna call it map base. I don't know, I'm just making it up as I go. So we pass that to the base class then. Instant compile error, because now we don't have a default constructor anymore. So now I can just try to compile this. Oh, what am I doing? Undo, redo, make. And then it tells us in the constructor, blah, 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 no matching function called to default constructor. And that happens where? Well, probably here. Yep. So here I'm trying to default construct my mapped segregated storage. But we can't do that. We have to pass the memory mapped file. Unfortunately, we don't know what it is. We only know that at the end. Like that's the value. Okay, so that means we do have to default construct it and then assign it later. I'm afraid there's no other way. Okay, back to the default constructor then. This constructor is not going to work. Let's call this then initialize. Initialize this simple segregated. I'm going to leave out base. Simple segregated storage and with an existing free list. So So void set head, very dirty. Do not do this at home. You can make it a tiny little bit more safe by demanding that head is still equal to the end of list. Here's the remark. Call this after default construction. Before using the segregated storage. I think pointers are easy. Mr. Never. They just point to memory and objects and stuff. Set head is really, you should never do that, except when it is initialization. I'm even leaving it here, directly under the constructor. And between the constructor and the destructor. That's where it should be called, so just so we know. And then this initialize can be called from the constructor of this thing here. No. Constructor of this thing here. At the bottom. Initialize virtual memory. How is this thing called? SSS? No, it's not called SSS. It's mapped SS underscore or not. Both. I don't think so. Yeah, that's what it's called. So I use underscores here, and then suddenly I switch to a prefix. No, I made it up. The usefulness is also questionable so far. Just make something up, and I don't really see it, and I think, well, just write it, and then things will explain themselves. And along the way, I got the feeling that probably it isn't the correct route, but well, what can you do? I've written stuff that took 20 years before it crystallized. Eventually, maybe it becomes something that's useful. Yeah, it's bedtime. Okay, so I call initialize on the mapped segregated storage object, and now it has a head pointer that points to the beginning of our mapped file. Yay. No more crash where it crashed. It's already called virtual memory here, so let's call it something else here. Start of the map memory. Okay, let's see. I don't know. Does it compile? Question mark. How many files did I change? That obviously does not compile because I wanted to go to bed. Void memory blah blah with is protected. Initialize is protected. Yeah, can't have that, can we? I probably have a billion initializers. Okay, I move it down. Damn it. Because I don't want to insert a public and then a protected there. Can keep it at the top here though. Initialize with blah 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 required from assert was not declared in this scope. How is that my problem? We live in a time of AI. Well, still have to do everything myself. Let's see. It compiles. That's one thing. Oh yeah, I was running something and then it's sec folded because nothing, right? Wrong tab. Core dump. Implement this. Ta-da! So that works. So now head points to the first, well, call it block, and that block has a next pointer equal to null. And that does no longer mean that that is the last block. It means that I have to implement something. So what I need to do here is to say, oh, is it null? Okay, in that case I set it to front node plus block size, the size of the block, which is only known to the caller. I'm going to call it node size, just because. I don't know, how does the caller call this? And is it size type? Do we have to do some cast here? Otherwise it's going to add this number of pointers. It's confusing maybe. I just first want to look at the caller. How is the caller calling this? Well, it's from allocate here, of course. I might as well pass it to allocate then. As in, instead of that that lambda that we had. So another question is, where is this allocate being called? Well, I don't know. Copy. I'm looking and looking and looking, and there it is. Took forever. This is inside the memory map pool. Now we should have all the information. The information is the virtual address, that's the start, and the total size. That's both of those we need. So I'm just going to pause that. Might as well use the same types then. So now the thing at the top. No, no mouse buffer then. What was it? Void pointer. Mapped. I don't know how I called it. Did I call it anything at all? Yeah, initialize was then. It's called it something. Head. Is that it? Yeah, horrible. Now this is already inside mapped, so I should probably call it the same as what I called it when I called initialize, which was in the constructor of beats me. Well, I thought this one actually, or not, doesn't have a constructor. No, of course it was the rar. Nope. Nope, 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 no, 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 no. This makes no sense. Actually, it does. Wait a minute. Yeah, so the only thing left is this initialize, which takes head. Here it is called virtual memory. No. It's the start of that. I'm gonna call it mapped base, whatever, man. Maybe I should rename this too then, to mapped base, because it's the exact same thing as where I use map base. That base and map size, it looks much better, doesn't it? Map base it is, and then I don't know where I was anymore. Yeah, really not. I think I was passing something to a function that takes two whatever. I think I passed one thing and it needed two or something. Node size was not declared. Completely. Oh, that. Yeah, that's what I was working on. That's true. Okay, let's make it a size type here. I think in the end I was going to pass a size type. I need both. Okay, so I don't know, man. Void pointer, mapped, base and size type, mapped size. Okay, let's call this mapped size then. Might as well do it correct. So the reinterpret cost, character pointer. Impossible. DQ, memory maps page, summaries, allocate. I can't find it. Okay. Oh, here. Yeah. Okay. That was already fixed then. It works. That is, it doesn't crash. Yeah. I can do the same test now, I think. I mean, now I have here how many bytes? 4 gigabytes. Is that enough? No, it's not enough. The test that I had used 17 gigabytes. Well, it's interesting enough to see that fail, I suppose. I'm just thinking how to do that. I hate code duplication. It's exactly the same as my memory test, except now I want to use a different memory pool. The memory page. So I can just replace this one line, but I'll do also need to initialize it, or do I not? No, maybe not. I can just global. Oh, ouch. Oh, let's call mmap from a global constructor. Why not? Yeah, theoretically it should work. Do we compare that with what I just had open? And the rest the same. So now it should be using a memory mapped file instead of allocated memory. And yeah, if it works, right? But my file is not larger than 4 gigabytes or so. This is going to allocate 17 gigabytes, so we definitely will get at the end of the list, meaning that at some point we have the head is going to point to the last block, and we'll read next is null, and then we will think that there is still another block after that, and then we will write to that. While it is beyond the mapped range. I think that should give a page fault, bus error or something like that. Let's just run it in GDB. Continue. Sec fault. That's very fast though. Can hardly imagine that it already allocated 4 gigabytes. Print fault node. Well, it looks big. But could still be in the range of our virtual memory. How to find out how big that virtual memory range is? Maybe we should just print it. Suppose you can go here, up. Yeah, so this is our current head pointer with a tag of 1. And that looks suspiciously much the same as this thing. I have the feeling that this is simply the beginning of our virtual memory. And we can't read from it, apparently. So much for memory mapped files. What the hell? Is this because I'm reading from a different thread and where I mapped it? No, it is shared. It is shared, isn't it? I mean, if it is shared, that should work. Okay, bedtime, because this is definitely in the realm of not quick anymore. I'll continue tomorrow.